Hello everyone, welcome back to my channel. Today let's go over a medium level question that I just solved on my own. So I'm super happy about this and I'm very glad that I was able to come up with my own solution to this problem without any assistance. So let's go over it and let me show you how I did it. This is number 3709, Design Exam Scores Tracker. So basically you want to record a time and a score and get the sum of all scores between a start time and an end time. So it's pretty straightforward. Basically, a default dict of type integer, self.cur time equals score, and then for I in range, start time to end time plus 1, because we want to include end time, then we're just going to add self.cur of I, okay, and then return total. So that's going to work, but this is a little bit too slow because this is n by itself. So and memory limit exceeded, because this is obviously a very big array. So if time is not in self.current, then do this. Self.cur time equals score. So, okay. So basically, that's fine. Default dict of type integer. So there's a more clever way to do it. And the way I did it was to use prefix sums. So basically, for each key value pair, so let's say we have a time and then a score. So we're going to record the time and the score, right? So we're going to want to have a sorted list because the time and the scores have to be start is less than end. So self.cur, let's define a sorted list, and self.cur.add time score. So the interesting thing is, let's go ahead and also do a default dict of type integer. So self.d time equals to score. So what we're going to do is discard if this key value pair exists. That's the beauty of the default dict. And then we're going to add the new time and whatever it was modified to, the value of this key, right? So if we want to change this to this, get rid of this, or delete this if it exists, and then add this. Okay, so that's what we're going to do. And then the way I'm going to keep track of the start time and the end time is using a bisection, which is going to find the first time. So this is interesting because we have to keep track of the time as well and the score. So self.times, let's call this a sorted list again. So self.times.add time. And then from here, let's also just say we have our values. So the time and the score, we're looking at the same index position. So that's going to be important. So let's just first run this bisect left into self.times start time, and then the end time. So now for I in range BL, be right plus 1, we're just going to add self.cur, because that's a sorted list, I of 1, so the actual score itself, and then return total. Okay, so okay, this is not correct. It's not supposed to include that, actually, I think. Let us see what is going on. So 1 to 3. Self.times. Yeah, so we're actually going to, we're going to use this, and we're going to keep track of this as the keys, and we're going to make this a sorted set because we want them to be unique. So 1 to 1. Okay, so, well, first let's just make this simple because I think I made this a little too complicated. Let's just do it the old way. So for k in self.d, if start time, it's in between, then total plus equals to self.dk, 0, return total. This is n, so it works, but it's going to be really slow. As you can see, just let's do the brute force first and take this step by step so you can get a better idea. Okay, come on. Okay, time limit exceeded 768. This is n. So now the idea I had was to add this. Yeah, discard. And then add. So now let's do the bisect left on the times. Same thing with n time. So let's print times BL be right. Self.times or 0 to 1. Okay, cool. So now we have 0 to 1, but we want the actual sum itself. So self.vals is just going to be self.vals.append score. Let's print self.vals. Okay, so we're just going to get sum of self.vals be left to be right. Nope. Be right plus 1. Yeah, it's supposed to be a bisection, I think. This is what we need, a bisect right. Okay, cool. So now that we have all the values and they line up, now it's about optimizing this, right? We just want that chunk of the array in the sum, and this is where the prefix sum pattern comes in, where we just basically accumulate everything. So 1, 2, 3 would just be accumulated as 1, 3, 5. And then if we want the sum of this subarray, it's just this minus this accumulated. So the accumulated array, the current minus left minus 1. So cool. So how do we do this? So if not self.p, then we're going to append just the score. Otherwise, we're going to append self.p -1 plus the score, right? So let's go ahead and print self.vals, self.p, just to make sure they're correct. Okay, you can see this is the accumulated version. So now if BL is less than or equal to 0, then you just know it's everything BL. So we can just return self.p of B right -1. Otherwise, we want to return self.p of the current minus PBL -1, as I showed you in the picture. Index out of range, and we have to make sure BL is less than B right, because there is no way to cross over. Okay, otherwise we return 0. Perfect, because BL has to be less than B right, because if we're getting 0 to 2, if we're getting this is 2 and this is 2 and this is 0, then how are we supposed to get anything? That makes sense. Okay, so now let's run this. Okay, and submit it. And there you go, passes all test cases. So again, I'm super happy that I was able to come up with my own solution to this problem without any help and solve it completely on my own. I think this is a pretty new question, which is why the runtime and memory are not published yet, but this is going to be log n instead of n for this call, and also log n for this, because this is an O of 1 operation. So each of the discards and the adds are log n. They use a binary search tree under the hood. So either way, that's it for this video, and thank you for watching.